This is the intro video for Algebra 1, Section 8.5, and as you know, throughout this whole unit, we've been working with radicals, and finally in 8.5, we're going to look at radical equations, which is to say equations that have a radical or two in them. So let's remind ourselves that the square root of a squared is equal to a. So in other words, the idea here is that the squared and the square root essentially cancel each other out. There are some other details you might learn about in some other classes in regard to that, but for now, we're just going to go with this. So when you look at an equation like number 1, it says solve. So of course, solve means isolate x, isolate the variable. So we're going to be solving for x. And so you look, as it currently stands, it's the square root of x. So if you were to ask yourself, is the x all by itself? The answer is no. So then how do you undo a square root? Well, you square it. So we're going to square the left side, and whatever you do to the left side, you have to do the exact same thing to the right side. So on the left, the square root and the squared will cancel each other out, leaving you with just an x, and on the right side, 4 squared is 16. So as I mentioned up here above, it says be sure to check your answers. You're going to find that, kind of like some other questions we've done in the past, with these radical equations, it's very possible to do everything right, make no mistakes at all, and then end up with a false answer or an extraneous solution. So we want to check these. So I'm going to take the original equation back right here, square root of x equals 4, and I'm going to check this by plugging in my answer. So it's going to be square root of 16 possibly equals 4. The square root of 16 is 4. 4 does equal 4, so I would say it checks, and 16 is actually a solution to this equation. Let's go ahead and take a look at one more. Okay, so you can see this one is a little bit more complicated, but at its core, it's very similar. It says solve, so again, we're going to be working to isolate x. And as you look at this, currently the x is buried inside of the radical here. So an important note here, I want to point this out because I've seen plenty of folks do things like this. You want to be really careful that you don't touch the radicand. You can't really do anything to the radicand at all until after you've dealt with the radical. So I've seen people do this. This is what I'm about to do here is wrong, so please don't do this. I've seen people try to do things like this. You're trying to subtract something out of a radical, and you simply can't do it. It's just mathematically incorrect to try to subtract a part of a radicand out. And what we need to do is we need to deal with the radical before we try to do something with the radicand. So in this case, the radical is kind of by itself there on the left-hand side. And so what I can do is get rid of the radical by squaring both sides. Right, so I'm going to square the entire left side and square the entire right side to keep this balanced. So as you probably are guessing, the radical and the squared will cancel each other out, leaving us with 4x plus 1 is equal to 7 squared is 49. And so then to solve this, now the 4x plus 1 is no longer a radicand because I got rid of the radical. So now I can actually subtract 1 from both sides. And so I end up with 4x is equal to 48. And then to finish off, I would divide both sides by 4. And so x is equal to 48 divided by 4, which is 12. Okay, so like before, we need to check this to make sure that we've done everything correctly and that that's not an extraneous solution. So I'm going to go back to my original equation, which is square root of 4x plus 1 equals 7, and I will plug in the 12 for the x. So this will be square root of 4 times 12 plus 1 equals 7. 4 times 12 is 48. And 48 plus 1, of course, is 49. And we know from before that the square root of 49 is actually 7. So 7 does equal 7. So that does check, meaning that 12 is a solution. So trust me, there will come a time or times when the solution we find is one of those extraneous solutions, and so we'll have to eliminate it as an answer. And so let's be on the lookout for those, and we'll check those sorts of examples out and others when I see you in class next time. See you then.